Hello and welcome to tribetopper.com.
And you're watching this video on important concepts of current electricity. In this video, we are going to discuss the factors affecting resistance and resistivity. Now, what do you think should be the factors that can affect the resistance? See, just look at it. If you have to travel a long distance, the chances of collisions are more. That means if the length of a conductor is very long, the higher the length, the more the collisions happen, and more the collisions means more the resistance, because resistance is because of the collisions, right? Therefore, that means the resistance of a conductor would be directly proportional to the length of the conductor, right? So that's the first factor which affects the resistance of a conductor, and that is the length of a conductor. You might have noticed that when we want the smaller amount of current to flow, we want a higher resistance for the wire. Like for example, you have a charger of your phone. They have a long wire. The wires are kept long so that the resistance is more and a small amount of current flows through the wire. The second factor would be, see, if this area is made the double, don't you think the collisions would be less? Obviously, if you're driving on a wide road, the chances of collisions are less, the chances of accidents are less. So, wider the road, lesser the collisions. Similarly, thicker the conductor or more the area of cross-section of a conductor, lesser will be the collisions and hence lesser will be the resistance. Therefore, resistance of a conductor is inversely proportional to the area of the conductor. And when we combine these two factors, we get this R is proportional to L upon A, and if we remove here the proportionality sign and add a constant, that constant is rho times L upon A. This rho, which is actually a constant of proportionality here, introduces the third factor that accounts for the nature of the material of a conductor. Right, so because the resistance of a conductor, if you have two wires of same length and same area, still they would have different resistance. So because the nature of every material is different, that means the third factor which affects the resistance of a conductor is the nature of the material, and that is accounted for by this constant of proportionality rho. Therefore, R is equal to rho times L by A. That's a complete expression which explains that the factors that affect resistance are the length and area and the nature, and hence mathematically we derive the relation R is equal to rho times L by A. Now, if you have a same material, if you increase the length to double, then what should be the impact on resistance? Now, if you increase the length to double by adding another wire of an additional length, that means the length increases but the area remains same. Therefore, in that case, that's a special case where your resistance would become twice of the original length, right? I've just doubled the length by adding another wire. So the area won't be impacted, just the length would increase, and therefore the resistance would become double. But in case I stretch a wire to double the length, that means I'm thinning out the wire, so the area would decrease, the wire would become more thinner and the length will become double, so the area at the same time would also become half. So in that case, the resistance will not just become double, it would become 4 times the original resistance. So these are some important things you need to take care while solving some numericals, where they ask us, like, a wire is stretched to double its length, what will be the impact on the resistance? So the resistance would become 4 times, because it's not just the length which has doubled, the area has also become half. But if it is the length is doubled by adding another wire, it doesn't impact the area, and so the resistance is just doubled. Similarly, if you have it for area, you thicken a wire by doubling on itself. So in that case, the length becomes half. So what should be the resistance? It should become L by 2 and the area would become A by 2. So we have thickened the wire, we have doubled the area of cross section. So how would the resistance get impacted? So we have the length becomes half and the area becomes double, so you have 1 upon 4 times A. So just take out this 4 outside. Inside you have rho L by A, which is the original resistance. So the original becomes 1/4. right? So the resistance becomes 1/4 of the original resistance. Hence, we say that the factors, see how they impact. So we have just doubled the wire on itself. Now that way we changed two parameters. We made the length half and made the area double. So that made the resistance of this conductor as 1/4. I hope you understood, and if you find this video helpful, please like us, subscribe us and follow us on Instagram and Facebook at PCM is no Rata. Thank you for watching.
Please follow us on Instagram, Facebook and Twitter at tribetopper.com.